Welcome, students. Today, we are going to explore some fundamental aspects of chemistry. Many of you might find chemistry intimidating, but that's often because the basic principles aren't clear. My goal is to help you understand these core concepts so that you can truly appreciate and enjoy this fascinating subject. To make this learning journey easier, I plan to upload a series of 3 short videos covering the basics of chemistry. These videos are designed for students from class 10 and above and will help you grasp the essential principles of chemistry. Once you watch them, you will find that chemistry isn't as daunting as it seems and may even become one of your favorite subjects. In this class, we will explore the structure of atoms. In the next class, we will dive into the concept of chemical bonding. And in the final class, we will focus on understanding the mole concept. So let's get started. Chemistry is the science that studies the composition, structure, and properties of matter. It explores how substances interact with each other, how they change through chemical reactions, and the energy changes that accompany these processes. Chemistry helps us understand the universe's building blocks from the simplest atoms to complex molecules and plays a crucial role in our everyday lives, from the food we eat to the technology we use. By studying chemistry, we gain insights into the natural world and develop solutions to many of the challenges facing society today. So as I already said, this is a branch of science which deals with matter. That is, it's precisely the composition, structure, and properties of matter. Now, when you talk about matter, we can define matter as anything that occupies space and has mass. Now, matter can be subdivided into the solid state, liquid state, and gaseous state. Obviously, there are other forms of matter like the liquid crystal state, the plasma state, and so on. But the basic 3 states of matter are solid, liquid, and gas. Now, let's find or distinguish between the 3 states of matter. When we talk about solids, this form of matter has a definite shape, a definite mass, and volume. And in this case, the building blocks of solids, that is the constituents of solids, whether it is atoms or molecules, there is a very strong intermolecular force of attraction between the atoms or molecules, or the constituents of the solids. And because of this very strong intermolecular force of attraction between the constituent particles in the solids, the particles are all actually well binded together. And we can say that they are in close proximity with each other. And as a result, these constant particles do not have sufficient space to move around. Because if they try to move, they will collide with the neighboring particles. So we can say that these particles have a very low freedom of motion, and the constant particles of solids have a very low kinetic energy. That is, they don't have any freedom of motion. The velocity is 0. You can say it's precisely 0 because these particles can actually vibrate. But anyway, for a rough estimation, we can say that they have almost 0 velocity or 0 kinetic energy. And matter in the solid state is incompressible. You cannot compress solids. So this is the basic properties of solids. So matter in the solid state have a definite shape, mass, and volume. The constant particles have a very strong intermolecular force of attraction, and the particles have a very low kinetic energy, and solids are nearly incompressible. So we can say that solids are the most ordered state, or in a thermodynamics viewpoint, we can say solids have the lowest entropy. Entropy is a measure of disorder. So the disorder-wise, we can say that of the three forms of matter, solid is the most ordered state. So the entropy is very low, or the disorder is low. So that's about the solids. Now, when you go to the liquids, liquids have a definite mass and volume. But remember, the liquids does not have a definite shape. They take the shape of the container in which they are kept. So liquids does not have a definite shape, but they have a definite mass and definite volume. The constant particles in the liquids have a weak intermolecular force. So compared to solids, the intermolecular force in a liquids is generally weak. And because of this, the constant particles in a liquid has a greater freedom of motion compared to that in a solid. So they have a moderate kinetic energy. The kinetic energy is not completely zero. They have a net velocity, or we can say they have a moderate kinetic energy. But just like solids, liquids are nearly incompressible. So solids and liquids are nearly incompressible. And the amount of disorder in liquids is greater than in solids, or we can say that in thermodynamic viewpoint, liquids have a greater entropy, or they have a greater disorder compared to solids. So that's about the liquids. Now going into the gaseous state, matter in the gaseous state only have a definite volume. The gases occupy, they have does not have a definite shape. It does not have a definite volume, but they have a definite mass. Sorry, I just need to correct it. They don't have a definite volume. Actually, they have a definite mass. It's not volume here. It's need to be corrected. They have a definite mass. So matter in this gaseous state does not have a definite shape. They does not have a definite volume, but they have a definite mass. Actually, the gas occupy the whole volume of the container in which they are kept. So gases occupy different volumes, and the volume will be equal to the volume of the container in which they are kept. But gas have a definite mass. And the intermolecular force in gas is the weakest. So solids have a very strong intermolecular force of attraction. Then when you go to liquids, the intermolecular force of attraction becomes weak. And in the gaseous state, they have the weakest intermolecular force of attraction. We cannot say it is completely zero. They still have a weak intermolecular force of attraction. If it had been zero, then you cannot actually liquefy gas, but you can actually liquefy gas. So that shows that there is a weak intermolecular force of attraction between the gas molecules, but it can be compared to solids and liquids. This intermolecular force of attraction is very weak. And because of this weak intermolecular force of attraction, the gas molecules have greater freedom of motion, or we can say that they have a very high kinetic energy. They can move about freely, and as a result, the constant particles have a high kinetic energy. And gases are compressible. You can actually compress gas. So these are the basic differences between solids, liquids, and gas. So that's the three basic forms of matter. Now, the basic building blocks of matter are atoms. We can say that the constant particles of matter are atoms. Matter is made up of atoms. Now, how can you define atoms? Atoms can be defined as the smallest particle of an element or a compound which are indivisible by chemical methods. This is the actual definition of an atom. It is the smallest particle of an element or a compound which are indivisible by chemical methods. So, here in this definition, we talk about element and we talk about compounds. I will come into that, what you mean by element, what you mean by a compound. But anyway, for the time being, we just understand that atoms are the smallest particle of an element or a compound which are indivisible by chemical method. That is, by chemical method, you cannot further subdivide an atom. But by nuclear methods, you can actually subdivide an atom into protons, neutrons, electrons, etc. But by chemical methods, that means by chemical reactions, you cannot divide an atom further. So atoms retain their identity during a chemical reaction. During chemical reaction, atoms remains as such. There's just a reorientation of the atoms. Now, atoms combine to form molecules. And molecule can be defined as the smallest particle of a compound which can exist in the free state. So that is the definition of a molecule. Molecules are the smallest particle of a compound which can exist in the free state. And by the very definition, you can see that molecules are stable, because the definition you can see that the molecules are the smallest particle of a compound which can exist in the free state. So that means molecule should be stable. What about atoms? Atoms may or may not be stable. There are atoms which are stable. There are atoms which may not be stable. So atoms need not be stable, but molecules are always stable. So in order to attain stability, atoms combine to form molecules. And when you talk about elements and compounds, if the molecule of a substance consists of only one type of atom, you can say that it is an element. If the molecule of a substance is composed of more than one type of atoms, then you can say it is a compound. For example, if you take hydrogen, H2, a hydrogen molecule is composed of two hydrogen atoms. So that's why you write it as H2. So in a molecule of hydrogen, there are two hydrogen atoms. So even though there are two atoms in that molecule, the two atoms are of the same kind, that is hydrogen itself. So we can say that hydrogen is an element. If you take oxygen, O2, a molecule of oxygen is composed of two oxygen atoms. So a molecule of oxygen has two oxygen atoms, but they are one and the same because they are all oxygens. So you can say that oxygen is an element. This takes sulfur. A molecule of sulfur has 8 sulfur atoms. So if a molecule of sulfur is composed of 8 atoms, but they are one and the same. They are all sulfur atoms. So we can say that sulfur is an element. So they are called elements. So if the molecule of a substance is composed of only one type of atom, it is an element. And when you go to the compound, if the molecule of a substance is made up of more than one type of atoms, it is a compound. That is, for example, if you take water, H2 is the chemical formula of water. That is, a molecule of water consists of 2 hydrogen atoms and 1 oxygen atom. So, in a molecule of water, there are altogether 3 atoms, of which 2 are hydrogen and 1 is oxygen. So, there are 2 different types of atoms in oxygen molecule, or water molecule, 2 hydrogen atoms and 1 oxygen atom. So, water is a compound. It's not an element, it is a compound. Yeah. So, this is what distinguishes between an element and a compound. Similarly, if you take sulfur dioxide, a molecule of sulfur dioxide is composed of 1 sulfur atom and 2 oxygen atoms. So there are 2 different atoms in sulfur dioxide. So it is a compound. Similarly, if you take sulfuric acid, H2SO4, a molecule of sulfuric acid has 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. So there are 3 different types of atoms in sulfuric acid: 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. So H2SO4, sulfuric acid, is a compound. So this is what distinguishes between element and a compound. I hope I'm clear. Okay. So coming back to our concept of molecules, as I already said, small molecule is the smallest particle of a compound which can exist in the free state. Okay. Now, as I said, atoms is the smallest particle of an element or a compound which are indivisible by chemical methods. So you cannot further subdivide an atom by chemical methods, but you can actually subdivide an atom by nuclear methods. An atom is further composed of protons, neutrons, and electrons. So these are 3 building blocks of atoms. Atoms are made up of protons, neutrons, and electrons. So when you talk about the structure of an atom, there are different ideas or which explains the structure of an atom. But when you talk about the structure of atom, the first model that comes to our mind is the Bohr model. You have the first model of an atom was proposed by J.J. Thomson by his famous plum pudding model. So then we have the Rutherford model of an atom. That model was he reached that concept by doing the famous gold foil experiment. Then after that, Niels Bohr proposed his model. So when after that, you have the Schrodinger model and quantum mechanical model, the different models, Sommerfeld model, etc. But when you talk about the structure of an atom, I think the first model that comes to your mind is the Bohr model, because that is the most simplest model and it can very well explain most of the properties of atoms. Obviously, it has its own flaws, but it is a very good model for explaining the structure of an atom. But anyway, all the model, there is no differences that actually say all the models propose that atoms are made up of protons, neutrons, and electrons. So there's no difference between these two models. On the concept of when you talk about the structure or the basic building blocks of atoms, protons, neutrons, and electrons are the basic building blocks of atoms. Okay. So coming at the Bohr model, an atom has a central nucleus, and around this nucleus, we have the electrons are revolving around the nucleus. And this model, so when you say about the nucleus is positively charged and electrons are revolving around the nucleus. So this is the nucleus is composed of protons and neutrons, and negatively charged electrons are revolving around the nucleus. So coming into this proton concept, the proton has a mass of 1.673 and 10 raised to minus 27 kilogram, and a charge of plus 1.6 into 10 raised to minus 19 coulomb. This is the mass of the proton, 1.673 and 10 raised to minus 27 kilogram, and a charge of plus 1.6 into 10 raised to minus 19 coulomb. So that indicates that a proton is positively charged. Now coming on to the neutron has a mass of 1.674 into 10 raised to minus 27. So a neutron is slightly heavier than a proton, or we can say that they have almost same mass. But exactly, a neutron is slightly heavier than a proton. So a neutron has a mass of 1.674 into 10 raised to minus 27 kilogram, and a neutron does not have a charge. That is, a neutron is electrically neutral. Now coming into the last one, that is our electron. Electron has a mass of 9.109 into 10 raised to minus 31 kilogram. That is, the mass of an electron is much smaller than a proton or a neutron. So we can say that an electron has negligible mass, whereas the mass of proton and a neutron lies in the 10 raised to minus 27 kilogram range. The mass of the electron lies in the 10 raised to minus 31 kilogram range. So, compared to a proton or a neutron, or you can say that compared to an electron, the proton or a neutron is 2,000 times, equals almost 2,000 times heavier than an electron. So compared to proton and neutron, electron has negligible mass. So anyway, its exact mass is around 9.109 into 10 minus 31 kilogram, and the charge is minus 1.6 into 10 raised to minus 19 coulomb. It shows that magnitude-wise, the proton and electron has the same charge, but when you check the signs are opposite. The value of the charge is same for the proton and the electron, but the signs are different. Proton has positive charge, electron has negative charge. So one proton can exactly cancel the charge of an electron. Okay, so that's about the proton, neutron, and electron. So in this three building blocks of atoms, the neutron is the heaviest, followed by proton, and an electron. Neutron does not have a charge. Proton has positive charge. Electron has a negative charge. Okay. And when we come to the structure of atom, the protons and neutrons are placed in the central part of the atom, and the central part is called the nucleus. So nucleus is actually composed of positively charged protons and neutral neutrons. Now, the protons have positive charge, neutrons does not have a charge, which indicates that the central part of the atom, which is the nucleus, has a positive charge. And negatively charged electrons revolve around the nucleus in fixed circular path called orbits. Now notice I'm talking about the Bohr model. Okay, not the quantum mechanical model, the Schrodinger model. I'm just talking about the Bohr model. That's why I'm saying that electrons revolve around the nucleus in fixed circular path called electrons. And this fixed circular path, according to Bohr, is known as orbit. Okay. And the orbit which is closest to the nucleus is called the first orbit. Or you can say this orbit are otherwise known as shells. So you can actually call them K shell or the first orbit, otherwise known as the K shell. The second orbit is known as the second orbit, or it is known as the L shell. Third orbit, which is larger than the second orbit, it is known as M shell, like that. So it's have a K shell, then L shell, M shell, N shell, O shell, like that. And the first shell is the smallest shell, then followed by the second shell, then the third shell, the fourth shell. The outermost shell is called the valence shell, and that will be the biggest shell of all in an atom. The smallest shell will be the innermost shell. And when you go outwards, the size of the shell increases. And each shell can accommodate only a fixed number of electrons. For example, if you take the first shell can only accommodate 2 electrons because of its small size. The second shell can, because of its larger size compared to the first shell, can accommodate greater number of electrons. That is, it can accommodate 8 electrons. Okay. The third shell can accommodate even more larger number of electrons. That is, it can accommodate 18 electrons, like that. But anyway, these are called shells. That is, electrons are revolving around the nucleus in fixed circular path known as orbit. And each orbit can accommodate only a fixed number of electrons. The first shell, second shell, third shell, as you move outwards, the size of the shell increases, and as a result, each shell can accommodate larger number of electrons as we move outwards. The outermost shell is known as the valence shell. Now, in an atom, the number of protons is equal to the number of electrons. So if you have 4 protons in an atom, there will be 4 electrons, which means that an atom is electrically neutral because the atom protons and neutral electrons have the same magnitude charge, but opposite in sign. The atom is electrically neutral. So if you have 6 protons, you should have 6 electrons as well. Okay. Here, the green part is actually, which is indicating the proton, and this red portion, red spheres, indicate neutrons. So the protons and neutrons are packed in the nucleus. And the electron, negatively charged electrons, are revolved on the nucleus. As I already said, protons and neutrons have a much greater mass compared to an electron. That means almost 99% of the mass of an atom is concentrated in the nucleus. Electrons, we can say that electrons have negligible mass. So the whole mass of the atom is concentrated in the nucleus. Now, compared to the size of an atom, the size of the nucleus is very, very small. And means by Rutherford actually showed, using his famous gold foil experiment, he showed that most of the space in an atom is empty. So when you compare an atom to the size of a football ground, the size of the nucleus will be around the size of a golf ball. which is actually placed at the center of the football stadium. But remember that the complete mass of the football stadium is now concentrated on this small golf ball. So you can just imagine the density of the nucleus. It is the whole mass of the atom is concentrated in the small region called the nucleus. And as I already said, the number of electrons that can be accommodated in a shell for an orbit is given by the formula n is equal to 2n squared, where small n indicates the number of the shell. For the first shell, n will be 1, second shell, n will be 2, third shell, n will be 3, and so on. So using this formula, we can calculate the maximum number of electrons that can be accommodated in each shell. If we take the first shell, n will be 1. So the first shell can accommodate 2 into 1 square electrons, that is 2. Second shell, small n will be 2. N square, that means 4. 4 into 2, 8. That means the second shell can accommodate maximum 8 electrons. When you come to the third shell, n value is 3. So 3 square 9, 9 into 2, 18. The third shell can accommodate 18 electrons. Fourth shell can accommodate 32 electrons, likewise. So using this formula, you can calculate the maximum number of electrons that can be accommodated in each shell. Now, remember that when you fill the electrons in an atom, the first two electrons, the first two electrons will go into the first shell. After that, the third electron will naturally go into the second shell, because the third electron can accommodate the first shell, because the first shell is almost full, because it can accommodate only 2 electrons. So if you add a third electron, that will naturally go to the second. So up to 10 electrons, if you add 10 electrons to an atom, first 2 electrons will go to the first shell, remaining 8 electrons will go to the second shell. Now if you add an 11th electron, that electron will naturally go to the third shell. So likewise, the electrons are filled in a shell. And in a shell, inside a shell, there are many subshells. And these subshells are named as S subshell, the P subshell, the D subshell, the F subshell. Shells are indicated as 1, 2, 3, or K, L, M, N. The subshells are indicated as S, P, D, F. Okay. In the first shell, there is only one subshell, that is the S subshell. In the second shell, there are 2 subshells, S and P subshell. So the here 1, 2, etc. indicates the shell, and the next alphabet indicates the subshell, type of the subshell. 1S means the F subshell, which is present in the first shell. 2S means the S subshell, which is in the second shell. 2P means the P subshell, which is present in the second shell. Now the third shell can accommodate as 3 subshells, 3S, 3P, and 3D. 3S means the subshell, which is present in the third shell. 3P means the P subshell, which is present in the third shell. 3D means the D subshell, which is present in the third shell. Like that. When you go to the fourth shell, you have 4S, 4 subshells, 4S, 4P, 4D, 4F, etc. So when you go away from the nucleus, or when the size of the shell increases, the number of subshells also increases by 1. Like this. Okay. Now, the S subshell can accommodate maximum 2 electrons. When you go to the P subshell, it can accommodate 6 electrons. And when you go to the D subshell, it can accommodate 10 electrons maximum. Remember that in each subshell, you have different orbitals. For if you take the S subshell, there is only one orbital, that is the S orbital itself. When you go to the P subshell, there are three orbitals present in the p subshell, that is px, py, and pz. When you go to the d subshell, there are 5 d orbitals in the d subshell. They are dxy, dxz, dyz, dx square minus y square, dz square. These are the 5 d orbitals. When you go to the f subshell, there are 7 orbitals present in the f subshell. Now each orbitals can accommodate maximum 2 electrons. Okay, not more than that. If you take any orbital, the maximum number of electrons that can be accommodated in the orbital is 2. No orbital can accommodate more than 2 electrons. So if you take the s orbital, it can accommodate only 2 electrons. If they take the orbitals of p subshell, any p subshell, if you take px, py, or pz orbitals, px can accommodate 2 electrons, py can accommodate 2 electrons, pz can accommodate 2 electrons maximum. If you take the d subshell, it's d orbitals. Again, we have 5 d orbitals, and each d orbital can accommodate maximum 2 electrons again. So take any orbital, if you take the maximum number of electrons that can be accommodated in an orbital is 2. So that means in the s subshell, you have only one orbital, that is s orbital itself, which can accommodate 2 electrons. That means the s subshell can accommodate only 2 electrons. If you take the p subshell, irrespective of whether it's 2p or 3p or 4p, etc., there are 3 p orbitals in the p subshell, that is px, py, and pz. Each can accommodate 2 electrons. Px can accommodate 2, py can accommodate 2 electrons, pz can accommodate 2 electrons. So that means total 6, 2 plus 2 plus 2. That means the p subshell can accommodate maximum 6 electrons. If you take the d orbital has 5 d subshells, and each subshell can accommodate maximum 2 electrons. 5 into 2, 10. That means the d subshell can accommodate maximum 10 electrons. If you take the f subshell has 7 f orbitals, each accommodating maximum 2 electrons. So 7 into 2, 14 electrons. That means the f subshell can accommodate maximum 14 electrons. Yeah, like that. So this is how the electrons are filled. So this is the order of subshell filling. First 2 electrons should go to the 1s subshell. Next electron will go to the 2s. Next 2 electron will go to the next 6 electron will go to the 2p, like that. And this is how you electrons are filled. This is known as the off-bow order. I'm not going into detail of this order. Let's just remember, have a shell. Inside that shell, which is shells indicated as first, second, third, etc., or K, L, M, N. Okay, and inside each shell you have different subshells, and this subshells are indicated as S, P, D, F, etc. And inside each subshells you have different orbitals, and the maximum number of electrons that can be accommodated in an orbital is 2. Okay. So this is electrons are filled in an orbital, and you can also just remember that the electrons have spin, just like this model which I'm talking about, the model of an atom. Just you can consider it as a planetary model. You have a sun in the middle. The sun, you can consider the sun as the nucleus, and the electrons or the planets are actually revolving around the sun. So the planets, you can regard these planets are electrons, and these planets are revolving around the sun in definite circular path known as orbit. Just like that, the electrons are revolving around the nucleus in definite circular path known as orbit itself. Yeah. And you have just one more thing I would like to add. There's electrons can also spin around its axis. As you all know, all planets also spin around the axis. Yeah, just like that. When you know that Earth spins from east to west, like that. The electron can spin, and the electron can spin only in 2 ways. Either the spin can be clockwise, or the spin can be anti-clockwise. So electrons can spin only in 2 ways. That is, one is clockwise direction, another one is the anti-clockwise direction. So if you have 2 electrons in an orbit, one electron will be spinning in the clockwise direction and one electron will be spinning in the anti-clockwise direction. So you cannot accommodate more than 2 electrons in an orbital. And the 2 electrons in an orbital should have opposite spins. That is what actually indicated by the Pauli's exclusion principle. It's actually the Pauli's exclusion principle that limits the number of electrons in an orbit, right? So the electron, just consider that, remember that electron can only spin in clockwise or either in anti-clockwise direction. Okay, so this is what I would like to take in the first class, that is about the structure of atoms. So I think I am clear to you. If you have any doubts, you can ask in the comment section. I will be very eager to help you. Okay, so this is about the structure of atoms. So next class, I will come up with the concept of chemical bonding. So with that, I wind up today's class. Okay, so thank you, students.